We're here. Welcome everyone to the 100th episode of Max Planck Florida's Neurotransmissions Podcast. I'm Joe Schumacher, joined by my fabulous co-hosts to celebrate what for us is a really major milestone in the history of this podcast. First up, let's just get right to the meat of this. This podcast wouldn't exist if it weren't for you, the listeners, who've been tuning in for, 8 years at this point. I can't believe we generated enough interest to drive us through to this point. What started as just a fun little creative project for three friends working in science really grew into a whole institutional effort with all these individual cameras and a wide shot and all this stuff, this video format, an amazing producer. And here we are, 100 episodes. It's really hard to wrap my mind around, but thank you to everyone who over the years has tuned in, hopefully learned some good stuff about neuroscience. Now, first up, let's just refamiliarize ourselves with the team. My co-host, my dear friend, Lesley Colgan.
Hi, everyone.
Thanks for being here. How are you feeling going into this 100th episode milestone?
I'm excited. It's a huge milestone, and you are one of the only hosts here who have been in from the beginning. So hats off to you. It's been a really fun couple of years since I've been involved, and I'm excited.
Yeah, I mean, every time I think it's winding down, I get brought back in, reinvigorated. There's always new guests. Also joining us today, longtime producer and co-host of the podcast, Cheng. How's it going, Jeremy?
Pretty good, Joe.
How does it feel to be here, 100 episodes?
It's a little surreal.
It's crazy,
yeah,
right?
We've come a long way.
Yeah. So Jeremy knows just like engineer Kevin, probably knows my voice and the problems with producing and cutting out my verbal tics and my lip smacking and my plosives and all this stuff more than anybody. What was your earliest experience working in the podcast? Before you were a co-host, I think you were helping us work through the backlog of all the editing we had to do.
Yeah, so I joined end of 2018, and you guys had a bunch of episodes you had recorded and I think we're waiting to be edited, so I kind of jumped in and got used to trimming out all those weird pauses and table bumps, and certainly I'm sure the listeners...
Table bumps, yeah.
The
mics were not on little booms or anything fancy like that.
The production quality is definitely upped since then. We have nice shock-mounted mics, all the cameras, as you mentioned, and now the video podcast, so things have really come a long way.
For sure. Also joining us, our newest addition to the co-host team, Akash Pal. How's it going, Akash?
It's going fantastic.
So Akash, how did we convince you to start jumping in on these interviews? What was your main interest in working on this?
I think I joined around the 90th episode, and then my first interview was with Jeremy. Jeremy and I were the co-host, and it has been a wonderful experience so far. Like, I always wanted to interview scientists that I see who do stuff like me, and I just wanted to, put their science out in the world, help so that, others can see, oh my God, these people like me are doing these things. It's just been a very wonderful experience.
That's great. Well, we're glad to have had you. It's a lot of work putting this podcast together. I think it's well worth the effort. I mean, we've met some really incredible people over the years, scientists and non-scientists who've all come through and shared their stories, their career trajectories. So many interesting, weird outcomes of interviews that we've had over the years. I've heard of guests on the podcast who recruited postdocs who were listening to it. I've heard, postdocs who were listening to the podcast get inspired in their research from hearing, like, people literally at the bench, like Lucas Groschner and others who were listening in real time to people talking about their research and made them really want to get those projects over the finish line. What are some of the most interesting stories that you think have come out of this time working on this podcast?
Well, I think it's been just, like you mentioned, the diversity of guests that we've gotten a chance to interview. I mean, one of the first, before I was really involved in the podcast, one of the first episodes that I actually remember listening to was actually on writing, which is maybe not surprising now that I'm involved in scientific communication. I think it was like episode 8.5 with David Furster. And then on the other hand, getting to interview, Nobel laureates, incredible leaders in the field of neuroscience. Patrick Kramer was a fun one because, he was just about to take the lead at the helm of the Max Planck Society, a really exciting time in his career. So, I think one of the most rewarding things for me is just being able to talk to all of these incredible people across diverse aspects of science, and feeling like you took a little part of sharing their messages with the world.
Yeah, I mean, we have a very large neuroscience-centric audience, I think it's safe to say. A lot of us have probably had the experience of going to SFN, and when you're sitting like in the audience for the presidential lecture, and up on the screen they're showing these videos of these classical scientists talking about their discoveries. That's kind of part of the motivation behind what we wanted to do with this podcast. Like, do that for contemporary neuroscientists, make this sort of like a living historical document of people who are doing really cutting edge, flashy, cool, eye-popping stuff, like during the course of actually recording the podcast, talk about research in progress. And luckily at MPFI, we have this amazing seminar series where all these cool people, our friends from around the country and around the world, come and share what's hot off the press for them. It also started a little bit as a scam because, a lot of us were, what's really fun about the podcast is it's always been postdoc driven. The podcast initially started with Ben Scholl, Misha Smirnov, and myself. Ben's now a faculty member, and Misha is now a data scientist at Google. And we just wanted more time networking with cool people. Like when you're a postdoc and you're trying to, push your research and figure out your career direction, it's really nice to meet people who you can emulate and learn from. So part of it was a scam just for us to have this little extra side grift of meeting people and giving them this royal treatment of podcasting. And now it's grown into this whole thing where we can't wait to figure out who's going to be in the next seminar series lineup so we can figure out who we're going to get to meet. In some ways, we're looking back on 8 years of podcasting with Neurotransmissions, but in some sense, we're going to be business as usual because we're going to have 3 amazing guests on this episode. And we're going to hear from our scientific directors here at MPFI to learn a little bit more about the history of our institute, what has changed over the years that we've been doing the podcast, where the institute is headed into the future, and a little bit about them scientifically as well. But it would be fun to take a little bit of a trip down memory lane and think about some of the highlights over the years. So, you mentioned the Nobel laureates that have been on this podcast. How many have there been?
I think 5, but 6 if you count Emmanuel Carpentier. But when she was here, she didn't win the Nobel Prize. But I think we can safely say 6.
That's right. So we've had 6 Nobel laureates on the podcast. Dr. Charpentier maybe got the neurotransmissions bump that put her over the top. Congratulations. And beyond Nobel laureates, we've had so many amazing people, from graduate students to faculty members. Some of the highlights for me, I remember one year, the first time we went to SFN to do the podcast on the floor at SFN. I think it was the first time that we did that. I don't know how it happened, but I was interviewing John Hamilton from the science desk at NPR, who, I listened to this guy on the radio all the time. I felt like I was talking to a celebrity, and he was talking about how does he put a story together about neuroscience. And I see him every year at SFN, just running around chasing down cool technology and cool stories. What are some of the other highlights for you guys?
Well, I loved when I interviewed Mark Anderman. We worked very closely in terms of the things we want to look into, and then that was the highlight because we talked some experiments. He invited me over to his lab to maybe do those experiments, so I think that was fantastic. That's my favorite on so far.
Yeah, I think our most listened to episode actually was one that Jeremy and you hosted on perception with Hillel Adesme.
Yeah. So I think that was a pandemic recording, possibly a Zoom recording. And that's amazing. A lot of the most listened to episodes are not necessarily the Nobel laureate episodes where you feel like this person's going to give you the secrets to like the most successful career, but people just generally talking about really fascinating topics like perception.
I think that's kind of one of the strengths of the podcast is we do discuss the science, but also often the most entertaining stuff is the stuff around the science, right? People's experiences. And I think that sort of dovetails into one of my favorite episodes, which was when we sat down with Jason Shepard, who has been studying this gene called ARC, right, that has all these uses in synaptic plasticity, and he finds this amazing new application where it's now forming these virus-like particles that signal across the blood-brain barrier. So like, I think those are the really interesting parts of our conversations. Is we talk about the science, but we also talk about like how people got to where they are now, and sort of the unexpected things that they found along the way.
Absolutely, and I mean, I think, I don't know why I always come back to this one episode, but and of course, this isn't about like picking what's my favorite episode of Neurotransmissions, but one of the things I really valued, and I bet there's a lot of people out there who are really interested in podcasts, just as a medium, interested in doing their own podcast. How would you get going? Don't be afraid to branch out from what you are comfortable talking about. So I come from a sensory physiology background, and I found myself interviewing this amazing director from a Max Planck Institute for metabolism. His name is Dr. Jens Bruning. He was talking about metabolism research, insulin receptor expressing cells in the brain, how different fatty tissues like burn calories and all this different sort of thing. And it's so outside the realm of anything that I was familiar with. And I think it was an early on episode, maybe 13, 16 or something in the process. And so I did this really deep dive on his research and really methodically plotted out how I was going to get him to explain what he does in a way that I could understand, hoping that along the way somebody else would. And I think I learned more about scientific communication just by going through that exercise than anything. So for whatever tangible benefit anybody got from listening to this podcast, I got 1,000 times fold more benefit just in terms of my own ability to help people understand really complex.
I do think that's one of the fun things about being on the podcast is we're all pretty well trained and have expertise in our own sort of section of science, but it's sort of this fun opportunity to as I like to say, play a little dumb, right, and sort of come at it from like a new perspective to see, and play like an audience surrogate, right?
Yeah. You can't play it too dumb. We have gotten some feedback in our inbox that maybe I'm a little too dumb to do this, but no, exactly right. Yeah, it's definitely a fun exercise.
Yeah, and I think we owe a lot to our guests for really taking out the time and wanting, putting an emphasis on science communication and really wanting to share their science in an accessible way to the broader public. And
yeah, absolutely. I think there were some times when you would talk to the guest, usually we do a little bit of a primer on, how to not bang on the table or how far to be from the microphone and that sort of thing. And they come in and you see this person that you really admire through their research actually seeming a little bit nervous when they step in there. And then by the end, they're like, that was really fun. Like, so for anybody who's interested in podcasting or putting something like this together, it's in your reach. It's super accessible. People really like doing it. It's a lot of fun. It's a fun, creative enterprise to engage in.
Having said that, I don't think we could probably do this without our incredible producer, Kevin.
That's exactly the point I was going to get to. It's not just about the guests. It's not just about the listeners. There's actually a whole team of people over the years who've stepped in to help make this podcast something that's accessible to the world. And why don't we get him out here, actually? This is Kevin Albertini. He's our producer extraordinaire, a creative genius, and the driving force behind a lot of our science communication and creative content that we at the Institute. Kevin, welcome to the podcast.
Thanks for having me.
So tell the listeners a little bit about, like, what does it take to make people like Akash and Jeremy and Lesley and I not sound too dumb?
I refer to myself as a civilian when I compare myself to you guys. And I get the privilege to observe how excited you guys are exploring all of these scientific advancements. And so my role is to contribute to scientific advancement by amplifying what you guys already do within these halls, but we find a way to invite people outside of here to the conversation. And that's essentially what my role is. You guys are already doing these conversations. Now we're just letting other people in on the conversation.
Oftentimes I think the biggest criticism you would give to me is that I would cut the episode too early because then the conversation continues afterwards, and you're like, why weren't we recording that part?
Yes.
Why?
So many times.
Yeah. What are some of the most memorable moments on the podcast for you? Maybe either from a scientific standpoint or from like a creative standpoint.
I really enjoyed the Daniela Sandler episode. It's been interesting to observe these prolific scientists that have come here and do everything from talk about how they got started or where they think the field is going to answering Akash's "Do you want Velveeta or Kraft mac and cheese?" and recognizing that they're people too, who are just very passionate about their area of expertise.
Well said. The whole push to move towards this dual audio video format was really, you were the driving force behind that, Kevin.
Yeah, there was a method to this madness in realizing that there's a multimodal approach to communicating the complexity of science, that there isn't one particular medium that fully encaptures it. And so we have found, Lesley and I both being in the communication department, we have found that if we're able to use different approaches to express the same thing, we have a better chance at being able to effectively communicate.
What comes next? So I think I made an announcement a couple episodes ago on the podcast that we're going to be going on hiatus after the 100th episode. Not to bring the mood down. This is actually good. This is a period for us to kind of like look and reflect on our creative vision for how we want to communicate science as an institute. I personally will be stepping down as a host of the podcast. Maybe if the podcast is resurrected in some new format, I'd be happy to join in on the guest side. So there's minimal preparation on my part. But what do you see as sort of the future directions of our efforts to communicate science to the world at large?
Part of my role within the communication department is to come up with random creative ideas. And part of my colleagues' roles are to tell me when to hold off on some of these ideas. With that being said, there are a couple of ideas that are in the works, that none of which we can go into any sort of detail right now. But it allows, with this podcast reaching its hiatus, it allows us somewhat of the bandwidth to reimagine the future trends coming for science communication, and coming up with different ways that I haven't seen done before, some of which will be digital, some of which will be in person, and some of which will be a combination of multiple things. Because like I said, a multimodal approach, which echoes what I've come to understand as being part of the Max Planck approach to science, is not getting stuck or bogged down and only doing things one way because we were doing things a certain way.
I still think, and now maybe I'm blowing up the spot on one of these top secret creative projects, I still think we should go to Roger Dean Stadium during spring training and take some pitches from major league pitchers and have Hidehiko explain the mechanisms of motor timing, just because I just want to have...
I would find it fascinating. I would be interested in doing that with maybe some slow motion cameras.
So I'm manifesting this. I'm putting this out in the world now. St. Louis Cardinals, Miami Marlins, you hang out in my neighborhood once a year for spring training. Let's make something happen here, guys. Well, Kevin, thank you so much for everything you've done to make this podcast as good as it can possibly be. I know you've made me look way better than I actually am, so kudos. Thank you so much. On that note, there's actually a lot of people we want to thank who've contributed to the podcast over the years, both on the interviewing side and on the production side. Shout out to Jeremy, who did a lot of the editing early on in the podcast. Kevin, of course. Big shout out to my dear friends Misha and Ben. We're no longer here at MPFI, but still are strongly in our hearts for getting this podcast up and running and helping to see it through for so long. A lot of our amazing guest co-hosts over the years: Audrey, Andre, Michael, Alex, Dan, Matt, Ingo, Paul, Verid. We might recall Verid actually did the voice intros and outros on our podcast early on. We had all these ideas of little bells and whistles and flourishes to add, and Vered was one of those. She had an amazing voice. People who worked on the production side, the communication side, Miguel, Jen, Katie, Kevin, of course. Can't forget our amazing executive admins here who helped us find guests. I'm thinking about Monica and Renata and Nicole, people who were scheduling seminar series speakers and helping to be this sort of diplomat to say, hey, we got this podcast going, do you want to be on it? So many people have contributed to every single episode of this podcast. There's not enough thanking we can do, but thank you anyway. Like, we really appreciate it. So, Lesley, what do we have in store for today?
Yeah, for the 100th and final episode of Neurotransmissions, we have not one, not two, but three amazing guests. The scientific directors of the Institute, Dr. David Fitzpatrick, who was instrumental in getting the podcast started. Dr. Ryohei Yasuda has also been very supportive, and Dr. Lin Tian, our newest scientific director here at the Institute.
Yeah, it should be a really interesting podcast. What are you guys looking forward to talking about?
Oh, no, definitely. I think it's going to be fantastic. I feel like we are in the renaissance of neuroscience. We have fantastic tools. We have fantastic scientists. And I think it's going to be a fantastic talk. And I just want to know where the directors think we're headed.
Yeah, I mean, it'll be really cool to look retrospectively of all the changes that have happened. Jeremy, what about you?
Yeah, I mean, I think certainly looking forward to the future will be very interesting, but also looking back at how things have changed as the podcast has gone on will be interesting. We have lots of different perspectives from the group leaders.
Yeah, absolutely. So, hope you enjoy this 100th interview for our last episode before we go on hiatus. We'll talk to you soon. What an amazing treat we have today. Joining us for the first time ever, all three of MPFI's scientific directors sitting down to talk about MPFI and the state of science. So all of you, thank you so much for being here today. And by way of introduction, let me introduce you to our newest scientific director, Dr. Lin Tian. Lin, thank you so much for joining us. So you just joined MPFI a little over a year ago. Your lab focuses on the development of biosensor technology for visualizing neurotransmitter release and other forms of neural activity. Thank you so much for joining us today.
Thanks for having me.
Absolutely.
Yeah, we also have our longtime scientific director and my former mentor, Dr. Ryohei Yasuda. Dr. Yasuda and his research have made fundamental contributions into our understanding of learning and memory and the mechanisms of those in the brain through the development and use of optical sensors to both measure and perturb protein function during plasticity.
And last but not least, you know him from our first episode of Max Planck Florida's Neurotransmissions Podcast, Dr. David Fitzpatrick, CEO and Scientific Director of MPFI. David's lab focuses on the functional architecture of the visual system, a long-ranging career covering a wide range of different visual systems and different critical visual representations. David, thank you so much for joining us today. The last time we talked to you was 2016. It's been a while since we've caught up. It's been about eight years. Back in 2016, you were really instrumental actually in helping us bring this podcast on board. You were really supportive of me and Ben and Misha doing this weird little creative project on the side. Thank you for that. I remember we were at our MPFI retreat one year and we were talking about this and how great that experience was. And Ben and Misha were big podcast fans. They love to listen to podcasts. It was a chance for us as postdocs to do deep dives into people's research careers, really sort of give ourselves role models to be thinking about our career directions, but also to share the cool cast of people who come through MPFI. We have this amazing seminar series and all these scientific events that bring people in. We talked a lot about the idea of Max Planck Florida Institute for Neuroscience when we interviewed you, sort of why it's a little bit of an outlier in terms of the general structure and organization of a research institute, at least for the United States, a little bit about introducing the United States podcast audience to the Max Planck Society's way of doing things. A lot has changed in the last 10 years. When you think back to those early days of MPFI in that sort of build-up phase of what we're doing and where we are now, where do you think some of the critical milestones have been for us? Like, what are some of the things you're most proud of over the last 10 years or so?
I'm so thankful that we had a couple of Nobel laureates that came through for us. And we also had the members of the biomedical section that came through for us and basically said that we need to continue to support this institute in Florida. They're doing really great science, and et cetera. So that was the tricky period. But, if I look back on what we've accomplished, I have to say it's exceeded my expectations in terms of the numbers of high quality publications. So start with the science, and then it's also the scientists. So 360 trainees that we've had in the Institute, 18 university professors. They're at various stages in their career, but, faculty, that number of faculty coming from this institute doing really first-rate neuroscience research.
Shout out to Ben Scholl, one of those 18, former podcast host for Neurotransmissions.
Yeah. And so that side of it is sort of at the top. But then you also think about how we've impacted the neuroscience community. We've had these conferences where we bring together so many people. Neuroimaging course, where we really bring, the people that are on the cutting edge of really creating these new technologies for imaging brain. When we started, I was constantly saying, I'm at Max Planck, Florida. Max what? What are you talking about? And I feel like those days are past. People understand what Max Planck, certainly in the scientific community, people understand what Max Planck, Florida is. There's this really unique neuroscience research institute in Jupiter, Florida.
Yeah. Now, you mentioned the neuroimaging course, and Ryohei, I actually, this is, something that you've taken very near and dear to your heart over the years. Thinking about things like the neuroimaging course and those types of programs, also the work going on in the labs here at MPFI, over the last 10 years or so, what have been some of the sort of scientific accomplishments for MPFI that you've been most proud of, either in your lab or at MPFI in general?
I'm certainly proud of what we have achieved in our lab. Being provided with a resource that we can do such research here and accomplish a lot of scientific discoveries.
Yeah.
So that's something I'm pretty proud of.
One thing I think about when I think about the Yasuda lab is these really amazing tools that you guys develop, and also novel approaches to imaging that open up resources for other people. Thinking about optogenetically silencing CAMK2 and things like that. What is your perspective on the adoption of these types of things that you're doing? And also, it's phenomenal to see the collaborations within MPFI. I feel like in the early days, labs were pretty siloed, but because of these different types of approaches you're taking, all the labs seem to be benefiting from each other. It creates this real ecosystem. Can you speak to that idea at all? Or?
So one thing is that although neuroplasticity is known to be important for obviously the brain function, but people are really focusing on the circuit circuit level analysis. And it's kind of difficult to access to the plasticity aspects. And also because there was no tools, the people really didn't even realize that actually the plasticity can be manipulated, and that can be useful to understand what's the neuroplasticity, which kind of eventually leads to the behavioral plasticity. I think I'm very proud of this kind of work because I think it provided kind of new perspective for the field. Actually, it took some time for people to start using our tools, right, to manipulate plasticity. Since we published, for example, photoactivator of CAMK2 a long time ago, it's like 7 years already. And I think recently people start to use more the tool, and I'm very, very excited that actually it took long time, but kind of actually kind of the impact slowly comes to the field.
Yeah.
Yeah, and I think it's sort of a testament to the environment that you guys have created here, that, we have this relatively small institute where people are talking, and these things always take time in science, but I think it's been fun to see the development of those collaborations and sharing tools and see sort of the new directions that your science can take. So, Lin, I'm actually curious, as the newest scientific director here, I'm wondering, do you actually remember the moment you first heard about MPFI, and what was your initial perception?
Actually, it's interesting. The first time I heard about places from Ryohei, I remember it's back in 2012. I was still a postdoc at the Gillinia Research Campus, HHMI Gillinia. I'm about to leave Gillinia to start my own lab at UC Davis, and we have this fluorescent protein meeting. And at that meeting, actually, Ryohei announced that he's actually leaving Duke and then will become this scientific director at MPFI. Everyone was so shocked because, you have a great career in Duke, right? And then, you're moving to Florida. So, but that's actually my first time, heard about this place. But then Ryohei talked to us about, how great this place is, and especially, the long-term vision for promoting, conducting cutting-edge neuroscience research. And also, this unique place of Max Planck Society's, legacy of excellent research. I feel like, this is actually a great idea, especially for Ryohei to move to a place, being able to work on big questions and to be part of this truly global community, right? So I was actually really excited for him at that time, when I was just about to start my own lab. So that's why I say, you never know where life takes you. And guess what? 12 years later, I'm here too.
Yeah, that's great. So in thinking about sort of your transition after you had opened your own lab and also had your own very successful, research program, what is it that ultimately, guided your decision to end up here at Max Planck with Ryohei?
I think you guys know, I'm also doing tool development. We basically develop technology to break the barriers. Our work is inherently high risk and high reward. As a scientist, I found myself has always been benefit to be in an environment or supported by the funding mechanism that can support collaborative, exploratory, non-hypothesis-driven, right, complex work that really require sustained time and effort. Right, so that's what Ryohei said. It takes 7 years to get those two to other people. It's a lot of risk, right? A lot of effort. You may not see you may not see the successful result immediately, but the impact will come later. So I saw the potential of this environment. When I was at Davis, I think especially with the initiative funding mechanism, I feel like I'm strived in those type of environment, but I see the potential of MPFI can bring this type of work to the next level. So that's why, I decided to move here, to be able to be fearless again. I feel like I really missed the time when I was a postdoc where I just started my lab. I feel like I'm fearless. I can just go, with the direction I want to go to really challenge myself to do hard things. But after 12 years in public school, I feel like, I have more fears because I have restraints. I can't really do things what I want to do. So coming here, I feel like I can be fearless again.
I love the way you phrase that, how, the structure of sort of the Max Planck model really gives you, freedom to be fearless and be bold. And I'm wondering if you have any specific goals for your own research or maybe for MPFI now that you've been here for about a year moving forward?
So maybe I'll start from my own research. So as you know, my lab focuses on development optical probes, especially focusing on neurotransmitter, neuromodulator, trying to understand how those molecules drive the brain activity and the behavior state. But if you think about the history of technology development, for example, calcium indicator, That's really revolutionized the system of neuroscience. It actually took 2 decades, right? It's not just develop prototype, but you still have to optimize and validate. So one of the major goal is we want to continue to optimize the sensitivity, the quality of this probe, so we can see better, we can see deeper, we can see with high resolution to really understand, the traffic of the brain. But we have to do this at a scale, right? So the purpose of doing that is also trying to disseminate to a broader neuroscience community, and with hoping that we can lower the barriers for everyone, from basic research, basic neuroscience, all the way to clinical neuroscience. They can apply those tools to be able to, or capable, ask hard questions. Yeah, so I think coming here, from one perspective, we'll continue to do those things, develop technology at a scale, but we're also excited to, collaborate with everyone, with Ryohei and David, to, develop novel tools to be able to monitor and manipulate other molecules, even disease biomarkers. So with ultimate goal to be able to drive the development of neurotherapeutics.
So, talking about kind of like this Max Planck model where these, amazing not to, gas you up too much, but these amazing scientific directors can come in with these big ideas and really do things at scale and have the resources necessary to push these tools. One of the other things about the Max Planck model that I think is really unique to MPFI, at least in the States, is the way that we sort of operate as a training basis, from not just from the grad students, but all the way up to our research group leaders. So, I think when we talked about this back in 2016, this sort of incubator type model where research group leaders come in and build their labs and get, a nicely resourced startup to essentially build a portfolio of their own independent research program was a little bit of an experiment for the American academic system. How do you see that playing a role over the last 10 years? What are some things that you've learned about that, and what are some of the strengths you think of that approach? Neuroscience is an incredibly dynamic interdisciplinary field. It's rapidly changing. Is there some aspect of that helps facilitate that acceleration of discovery in some ways?
I feel like, giving, highly talented scientists an opportunity to focus on establishing their scientific research program journey without, how do I say it, the other things that normally happen to a new faculty member at a university, where you have to be involved in teaching and so on and so forth, but really allowing them to focus on their science. I think it makes a huge difference. It also doesn't hurt to be having the resources to get started, and to being in an environment where you have core facilities that can enable your lab to do things that are on the cutting edge of technologies, and collaboration, collaboration with the directors' labs, other research group leaders. I just think what we have here is, I think it's a great model for getting science, for a young scientist, getting their science up and running. I really do.
And Ryohei, and you and David have overseen now an entire generation of research group leaders establish themselves and move on to the next phase of their careers. What are some of the biggest success stories, in your opinion, of some of the labs that have come out of MPFI?
Yeah, I think that the program was remarkably successful, although there was skepticism in the beginning, right, about the model. But in thinking about the program, it's really great that you can have annual resource, and you don't have to worry too much about writing grants and just start your program. So I think actually the group leaders achieved to create great programs here, right? And everybody so far got a tenured position. So it's really
Can't do much better than that.
yeah, exactly, right.
pretty
That's
incredible.
I think it's pretty amazing success story of the program.
You know what's funny is, now that I'm really integrated in some of the core facilities side of things, I'm still seeing, external recharge or external, charges. Jason Christie, Machine Shop, Sam Young, EM Core. They're still here. They might not be in the building, but they're still interacting with us on a scientific basis. And it's really great to have that, continuity. It's nice to see University of Colorado and all these other places in the mix of people who are doing business with us. So yeah, I agree. I think it's a phenomenal success rate.
Yeah, also, right, so I started my lab at Duke, right, and what you do when you're starting a lab, right, it's not easy, right, just so first coming to the university, you don't have your room yet, right, and it takes at least a year usually to just get your room ready, and then you are asked to write grants immediately before you even establish your program, right? And then it becomes your job really to just continue writing grants, and that I think actually I think some people at least lose their excitement quickly, right? Just becoming daily job to write grants and do and do feasible projects. But here you can do whatever they want, they dream of, and I think that's really the key of the group leader program here. It's really very different from starting your lab in the universities or other research institutes.
Yeah, it's a really interesting point. You get into science for the science, to be at the bench, to be doing the experiments, and you're trained at that until one day you're not a postdoc anymore, you're a faculty member, and the job you've been trained for is suddenly not the job that you're doing in a lot of cases. So MPFI sort of lets you continue to be in the zone of where your comfort level is and where your strengths are, and I think that's really interesting.
Yeah, again, I feel like, I can see both worlds, right? I was trained at the HMIT Linear, where you are enabled to ask hard questions, because we needed to be able to, as a scientist, we needed to work on hard questions. We needed, to be able to challenge ourselves. And then I moved to, start my lab at a public university. There are definitely constraints, but I feel like that the scientific approach, the spirit, will go with you, right? So now I can see, for example, our current group leader, most of them has this high risk, high reward DP2 grant mechanism, which already speak to, the spirit of MPFI, right? We encourage people, we enable them to work or ask hard questions. Everything is possible. Yeah. Lower the barrier. I think it's really important.
Mm-hmm.
It's been clearly a very exciting time over the last 8 to 10 years at MPFI, but I'd say more broadly in neuroscience in general. I mean, I think it was 2013 that President Obama announced, the Brain Initiative, which, infused a lot of funding into neuroscience and also focused a lot on these cross-disciplinary, big team science type of work. And I think it would be fun to actually just sort of reflect back a little, since we started this podcast in 2016, on sort of what do you think the biggest advancements have been over this period, either in the field or in your labs? How has this affected you?
I feel like, Brain Initiative is so important. It's basically made my career successful. Especially my research program is very high risk, high reward. It's not very hypothesis driven. It requires collaboration and very exploratory. I feel like Brain Initiative really helped to, it's kind of like a catalyst for collaboration for team science, right? So the team science requires technology, right? So I think that's one achievement Brain Initiative is to promote team science, to broader collaboration across discipline. And also think about all the technology development, all the technology that actually made it possible from the Brain Initiative, large-scale recording, high-density probes, sensitive molecular probes for monitoring manipulation. think about connectome, the scale of connectome. Brain atlas, we have a map into the brain, the roadmap of the brain. The very large scale circuit mapping, we now understand how the brain regions are connected to each other, how they talk to each other to drive a behavior. And we have, AI-based behavior analysis, right? So we can really break down to granular about, how the animal really behave, and then we can correlate the neural activity to behavior. Theory, computation, like all those large-scale data set. How can we collaborate with computational scientists? They take all this large data set, the data set are coming from all kinds of labs through collaboration, enabled by Brain Initiative to be able to come up with new hypotheses or refine theory that can be further tested at experimental level. So I feel like it's just incredible, successful 10 years, and we need to continue.
The motto of MPFI that we I don't know if we unofficially or officially adopted in the early days, is a quote from Max Planck that insight must precede application. And, like you're talking about, there's been this tremendous injection of resource and funding for tool development, analytical tools, diagnostic tools, biotechnology. I think we've had a lot of fundamental insights too, about basically things like you talking about bridging the synaptic level to the circuit level and understanding how synaptic plasticity in spines translates into behavioral plasticity in animals and those sorts of things. And so we're starting to have these really major insights that are driven largely by this technology development. Are we now reaching like the application phase? I mean, are we always going to be kind of in this this sort of finding new sort of granular types of insights? Where do we think like maybe some of the biggest directions that we want to deploy some of these technological advances would be?
In my opinion, we are not in that phase to really, so we can of course analyze whatever we got, and there are huge amount of data acquired through Brain Initiative and all other efforts. And it's really amazing time that we really can even write a paper without doing any experiments. There are huge amount of data available. I think it's true that, for example, anyway, we don't need to go too much there, but it's actually, there are huge amount of data already, and also to even we can mine the data, which might be actually extremely important because people took a lot of data without a lot of examination and analysis. And also there are so many tools already available, and it's great time to be a neuroscience scientist and to discover something that whatever you want to analyze. But I think actually there are a lot of questions we still can't ask with existing tools. And one of the things to me, is we even don't know, for example, how, we really can't connect the molecules and physiology and behavior yet. I think actually there's a huge gap between physiology and even the terminology is different. We don't have a really great idea how to connect these different areas, right? So
is that a technological limitation or a conceptual limitation?
It's actually probably both, right? If you have new new concepts of how to bridge the gap, then probably most likely we don't have the tool for that because we haven't really come up with the idea. So most likely we need to go together, right? Conceptual model and then new tool development to test the new models. So probably it will continue. It's important to continue, right? Doing the tool development and also kind of trying to fill the gap.
It's actually really funny because, again, this comes full circle in a weird way to the last time we talked to David on the podcast. We talked a lot about asking the right questions. Like sometimes it's not just about having all the right tools, but it's about knowing how to deploy that tool and ask the right question. Because, you know, like you said, big data is a huge problem for neuroscience. We have all these amazing technologies. I think about neuropixel probes. I think about, you know, large population level circuit mapping and functional imaging and optogenetics and holography and all these things. You can collect so much data and barely scratch the surface of the meaning of it if you don't have the right question to ask or the right, you know, the right conceptual framework to work within. So maybe we're perpetually in this insight precedes application phase.
You know, I think Ryohei's spot on here. There's so much we don't know, really, just in terms of the fundamental organization of networks in the brain. And what gets me very excited, work in my lab, but recognizing that we still don't have a clear picture of the functional properties of excitatory and inhibitory inputs to individual neurons and how that changes during learning, for example. Really? We don't know that? You know, for a long time we've been dealing with this in terms of cells being like little circles with arrows coming in, but not really understanding the integration that each neuron is contributing to the networks that give rise to behavior. And I feel like we really need to bring that down to the synaptic scale, the molecular scale, and understand the plastic mechanisms that change those inputs to give rise to behaviors that are flexible, right?
This has been a great discussion. Thank you all so much for joining us and sitting down to talk about kind of the state of MPFI, the state of neuroscience, and helping us to celebrate this, you know, amazing milestone for the podcast. It's been a long time coming, but we're just about out of time, and I thought a really nice way to bring this full circle might be to revisit the last question I asked you when you were here in 2016, David. Not to put you on the spot too much, but you know, if there's one message that you want people listening to this podcast, and again, you're talking to an audience of grad students, postdocs, you know, faculty level people in the general public who just have a passion for the brain and the passion for learning about neuroscience. What's the one thing you would want them to know about who we are as an institute and what we hope to achieve here?
Well, as an institute, we put science first, we put research first, and we create an environment where scientists who are running labs, postdoctoral fellows, and graduate students get to really focus on the science. And what I love about this environment is that you'll go into an experiment with an idea that you're trying to test, and you'll see something that you don't understand and you never imagined seeing something like that. And you have an opportunity in this environment to go after that and find out what that is, what that means. And where does that go? That leads you to a discovery that no one else has. So the freedom to explore novel things that emerge from your research is what I am so proud of in this environment.
Well said. Well, on behalf of the entire team behind the Neurotransmissions Podcast, David, Ryohei, Lin, thank you so much for sitting down with us. And thank you, our listeners and viewers, for joining us on this amazing ride. It's been a real pleasure to, again, hitting my mic. I'm classic audio goof on my part. But thank you so much for sticking with us over these past 100 episodes. It's been great hosting this along with Lesley. Lesley, thank you so much for piloting this ship for the last few years. It's been amazing working with you. And we'll be seeing you. Take care.